Okay, so I'm really going to be building off of the studies that Mitch and Retta presented earlier today. And we're using the results from their targeted grazing studies to measure what the potential effect of those targeted grazing treatments are on wildfire behavior. And so as you can see, you've already seen this picture before from Retta, but that's from the Arizona study site. Before I get too far along though, I would like to make a couple of acknowledgements. When we first started messing with the fire models, we realized that there was no such thing as a BehavePlus for dummies. And so in order to get through BehavePlus and FlamMap, we really relied on the knowledge and the patience of Tessa Nicolette outside of Arizona with the U.S. Forest Service. Also, this research was made possible through USDA AFRI grant funding. And of course, there was an excellent research team, most of whom you've already heard from today and will hear from later on. Kind of setting the background for why this research was important was, if you're like me, over the past 2 summers it's nearly impossible to open up the newspaper or get online and go to a news source without seeing these type of headlines. We've seen an increase in the number of wildfires in the western United States, so we're seeing more fires, and each fire, the average size has become larger and larger. So this wildfire issue isn't going away anytime soon. Where is that issue more important to address than along the Wildland-urban interface? The Wildland-urban interface is an area where homes and communities intermingle with undeveloped vegetation. And because of that, there's a lot of conflict that exists with these communities and the environment. Despite those conflicts, though, there has been a significant growth in these areas. In 2002, it was estimated that almost 40% of new home development in the western United States occurred in these areas. And that creates an interesting problem for fire managers for 2 main reasons. The first one is, in the event of a wildfire, these are the homes and businesses that are going to be under attack that they really want to address incoming fire on. But the second part is as these communities developed, it changed the fire regime in these areas. So fuel started to build up, which only adds to the problem of increased wildfire danger. When you add the social dynamic of having homes and communities in these areas, it's harder to rely on traditional fuel management methods such as prescribed fire and herbicide treatment. And so we've had to come up with more creative ways to manage those fuel loads. And we were looking at the question, could targeted cattle grazing be a potential treatment? And Dr. Howery kind of went over some of the reasons why we would look at cattle grazing instead of sheep or goats. Kind of to further emphasize that, there's just generally more cattle available in the United States, which means that we have more numbers to use for these treatments, and also there's more knowledge. People are more comfortable with using cattle, and there's not quite the same amount of knowledge base with sheep or goats. So we're hoping that targeted cattle grazing will alter fuel characteristics enough to alter fire behavior. By grazing, cattle can impact 3 types of fuel characteristics. That would be fuel load, fuel bed depth, and fuel continuity. And those 3 characteristics really play into how the fire burns. Because of the nature of targeted cattle grazing, we're looking at impacting primarily fine fuels. And previous studies have shown that cattle grazing can make a difference. Some of the earlier presentations have already made reference to this study. Following the Murphy Wildland Fire Complex in Idaho and Nevada, LaunchSpa et al. Went in and saw the differences in how the fire burned in areas that had been historically grazed to those that had been ungrazed. And you can see from these fence line comparisons where areas that hadn't been grazed before burned quite differently than the areas that had been grazed before. I do want to note, though, that this study also concluded that the effects of grazing were successful under moderate fire conditions, but as those conditions became more extreme, the effects of grazing were undershadowed or overshadowed by the other fire characteristics. The objective of this study was to evaluate the impact of targeted cattle grazing on wildfire behavior. We justify this project because of the Wildland-urban interface problem and the increased wildfire behavior in those areas. We hypothesized that targeted cattle grazing will affect fire by reducing flame length, fire rate of spread, fire line intensity, and acres burned. The basis of this study was off of 3 targeted grazing studies. The first one is at the Corona Range and Livestock Research Center, and that's in central New Mexico. We actually didn't use that study because the targeted grazing treatments did not alter fuel loads or field bed depths. But at the Santa Rita Mountain site, which I apologize for the SRM acronym, that was the easiest for our study, and at the Chihuahuan Desert Range Research Center, which Mitch and Retta had both talked about, targeted cattle grazing was effective at reducing those fuel loads, and we used the results of that study to measure the effect on fire behavior. The 2 fuel characteristics that we looked at were standing herbaceous crop, which was used as an estimate of fuel load, and stubble height, which was used as an estimate for field bed depth. From those studies, we found that targeted cattle grazing averaged between both sites were able to reduce standing fuel loads by 11 kilograms per head per day, or about 25 pounds per day. That was a 45% reduction in fuel loads at the SRM site and a 44% reduction at the Chihuahuan Desert site. Both of these reductions in fuel loads were statistically significant. And fuel bed depth was measured using stubble height on key forage species of both the sites. So at the SRM site, that would have been Lehman lovegrass, and at the Chihuahuan Desert Range Research Center site, that was Mesa dropseed. Only at the SRM site, though, were we able to statistically significantly reduce that fuel bed depth. That was a 36 centimeter reduction, and at the Chihuahuan Desert site, it was a 15 centimeter reduction, but with a p-value of 0.228. And I want you to remember the results of these targeted grazing sites. We'll be discussing those later and the implications of that. Moving on to the fire behavior modeling, we used 2 models that are available through the U.S. Forest Service and the Joint Fire Science Program. They're BehavePlus and FlamMap. And the reason we used the 2 models was because they're both different in the characteristics that they have. BehavePlus will evaluate fires at a single point in time, so it doesn't take into account a spatial or a temporal scale. The advantages of BehavePlus, though, is that it allows you to manipulate up to 2 different characteristics at once, so you can alter and evaluate the fire behavior for a range of fuel bed depth and fuel load. FlamMap, on the other hand, will evaluate fire on a spatial scale. So it uses GIS layers there's 7 of them that take into account landscape and fire and fuel characteristics. And so that's measured at a very specific site. The problem with FlamMap, though, is that it doesn't take into account temporal changes of the fire over time. One important input into the model was fuel moisture. And the reason fuel moisture is important is because that determines how readily the fuel will burn. Fuel is categorized into 2 different areas. We have dead fuels and we have live fuels. Dead fuels are further classified into 1 hour, 10 hour, and 100-hour fuels. And what that 1 hour, 10 hour, and 100-hour means is it's based on time lag, or the amount of time it'll take the fuel to reach the equilibrium moisture of its environment. That's closely related to diameter, so like the 1 hour fuels are less than 1/4 inch in diameter. With the live fuels, those are further classified into herbaceous and woody fuels. So applying targeted cattle grazing to these areas, we were mostly concerned with the herbaceous live fuels. We built 5 different fuel moisture scenarios to model fire behavior at. We used moderate, dry, and very dry conditions. And what these 75th, 85th, and 95th percentiles indicate are weather percentiles. These are site-specific as well, and they're measured during peak fire season for each site. So for example, the 75th weather percentile indicates weather conditions that are only exceeded 25% of the time during peak fire season, which is from May to September. Within the fire models, there's also preset conditions, and we use 2 of those that are titled the D2L2 and the D1L1. And these fuel moistures will indicate These fuel moistures are what determines the moisture of each of the 5 fuel classes that I had gone over in the previous slide. So using BehavePlus, there were 2 main vegetation types that we were concerned about. We were concerned with a grass type and a grass shrub type. There was a constant slope of 5% that we had input into the model, and we had a wind speed of 8 kilometers per hour at mid-flame length. And within the model, based on the targeted grazing studies, we did alter fuel load and fuel bed depth. Here are the results from the SRM site. And what I really want to focus in on is there's a critical threshold in firefighting that they use for fire management. When flame lengths are above a 1.2 meter flame length, your direct hand crews are actually pulled off of their direct line, and they're used for more indirect attacks, and you have to use mechanical treatment and indirect attacks to fight the fire. The numbers above the bars indicate what the flame length decrease was under pre-grazing and post-grazing treatments. And I want to point out that in the grass vegetation, we were effective at reducing flame lengths in the D2L2 75th percentile and D1L1 weather conditions. And for the grass shrub vegetation at the SRM site, we were only effective at reducing those flame lengths in the D2L2 scenario. And even though we weren't able to drop the flame lengths below that critical threshold in all the scenarios, we were still able to have a pretty substantial difference. And to get a better feel of how flame length responds to the grazing treatments, here's some 3D graphs at the 75th weather percentile condition, and you can see how the flame lengths move from a pre-treatment to a post-treatment condition in both scenarios. So you have your fuel load here at the bottom and your fuel bed depth here, and you can see how that moves gradually up as those increase. And again, for the Chihuahuan Desert Range Research Center site, here's the flame lengths, and here's the decrease as above the bars. And only at the D2L2 in the grass vegetation were we successful at dropping those fuel load, those flame lengths below that critical threshold. What these preliminary results indicate is that targeted cattle grazing is probably limited to grass sites. And that goes into the nature of targeted cattle grazing, where we can really only impact those fine fuels. So we didn't have much of an impact on the shrubs on those sites. And so when you introduce shrubs into the mix, we weren't able to decrease those flame lengths. This also indicates the importance of reducing fuel bed depth. Only at the SRM site were we able to significantly impact fuel bed depth, and that really showed in the results from the flame lengths that weren't reduced at the Chihuahuan Desert Range Research Center site. In the study, we didn't measure fuel continuity, and fuel continuity isn't an input for the models in either of the fire models either. So it just assumes that there's a constant fuel load, which isn't the case, but that does have an effect on the way fires burn that we weren't able to account for. And I think these results really suggest that you need to use a combination of fuel treatments when you have more than one type of species that you're targeting. The other things that we looked at in BehavePlus were fire rate of spread. And from here on out, I'm just showing the results from the grass vegetation site, since that's where targeted cattle grazing was effective. And the numbers above the bar show the decrease in percentage of fire rate of spread. That measures how quickly the fire moves. And the other thing we looked at was fire line intensity. Fire line intensity is indicated in British thermal units per second per foot and measures the rate of energy released during a fire. It's closely related to flame length and fire rate of spread, but it's another output that people will measure fire behavior on. And the numbers above the bars indicate by how much we were able to drop that by. Moving on to FlamMap, since it is a site-specific program, we chose to model fire at the Santa Rita Mountain site. We modeled a reduction in fine fuels, which is consistent with the targeted grazing treatments. And we used a moderate fuel moisture scenario. So that was modeled at the 75th weather percentile for that site. There was a southwest wind at 24 kilometers per hour, and we had a treatment size of 60 hectares, so that was a 1/4 mile by a mile strip, and the simulation ran for 8 hours. To get a better idea of what we were looking at, the green strip right here, if I can get this to work, is what we modeled as our targeted area. And similar to the BehavePlus results, here's what our flame length looks like. And the colors, the yellow and green, are the flame lengths that are below that critical threshold. The orange and red are colors that are above that. You can really tell how the weight of the flame lengths, how it shifted back under the treated scenario. Here's what fire rate of spread looked like. And here was the changes in fire line intensity. Because FlamMap incorporates the spatial model, we were also able to account for area burned. The red lines indicate how the fire spread under the untreated scenario, and the blue lines indicated how the fire spread under the treated scenario. The furthest point of spread we had in the fire was down here, and between the treated and untreated scenarios, that was about a mile difference. I want to note here that when we ran these models in FlamMap, we didn't have any type of treatment, so there was no firefighting efforts that were accounted for in these models. So this is clearly just allowing the fire to burn. So I guess the bumper sticker question for this project is, did targeted cattle grazing make a difference? And using BehavePlus and FlamMap, we were able to indicate that yes, we were able to reduce fire rate of spread, flame length, fire line intensity, and area burned. I do want to point out though that these conditions are highly variable with some of the conditions that could exist during a fire. We modeled a fairly light wind speed, so if that wind speed were to increase, it would change the results of this study. It varies with temperature because that's closely related with fuel moisture, and for the most part, these treatments were effective in moderate and lower conditions. And most importantly, we decided that you must target sites with the right fuel characteristics. So in the case of targeted cattle grazing, in order for it to effectively fight fires or to have an impact on fire, it would have to be a mostly grass-dominated site. I do want to point out though that using targeted cattle grazing could also be used to make more manageable fire zones. So it could be areas that you know where you can run a back burn on, and it might not be limited in those scenarios to just these sites. With that, I'm going to leave it to any questions that y'all might have. The landscape that comes to mind first of all would be along slope lines, and I think Dr. Terrell, are you going to be bringing up the Nevada studies where they actually put those along the Wildland-urban Interface? And I don't know what the strategy was for that, but you do make a valid point with that. Right, that would probably be the next step to take this to the next level. Yes, sir.